Okay, this question says, let f of x equal this integral function. At what value of x is f of x a minimum? So we have two ways in calculus of finding when a function has a minimum. There's the first derivative test, which means that there's a minimum if, right, so there's a minimum at x equals c if, the f prime changes sign from positive to negative. I'm sorry, negative to positive at x equals c. And then the other, right, negative would be in the function's decreasing, so that would make a min. The other way is the second derivative test. And the second derivative test says that you have a min if, so two things, you need a critical point, so that needs to be true. And then the second derivative evaluated has to be greater than 0, right? So this first derivative equaling 0 at c means, you've got a horizontal tangent. Second derivative being positive tells you it's concave up in that interval, in an interval near c, and that means that's the shape. So which of these we're going to use? Well, let's see if we can do the first derivative test, learn what we get there, and then if we think we have to be quicker to move to the second derivative, we can. So the first derivative of this function, by the fundamental theorem, is e to the, I'm just going to put the x squared minus 3x in for my t, so it becomes squared, and then don't forget by the chain rule, I then times this by 2x minus 3. So that's a common thing for students to forget. A lot of students forget this chain rule. We want critical points. Sorry. We want critical points, so we got to set the derivative equal to 0. Now, there's a fact that's very useful to know because it comes up so much in like a BC Cal class, and that is that this, right? So now I've got like two things multiplied to 0. This can never be 0. Can never be 0. It's an exponential. Exponential functions, ignoring like shifts and transformations, all that stuff, or vertical shifts, I should say, or it can never be 0, right? I mean, you can set it equal to 0 and try to solve. You're going to get like the log of a, you're going to end up getting like just a function that has no solution, or an equation that has no solution. But e to the anything, I mean, is always a positive number, because the e to like anything is just going to have this look, right, where this is the x-axis and this is the y-axis. So this is not contributing anything, and you can remember that. Like if that's a nice short like hack to like let you know that we're the only thing that's going to become 0 is this. So I know I paused on that concept, but if you're watching this, that is like a algebraic or just like an understanding of functions that can like expedite this problem. So that must mean that a critical point happens when 2x minus 3 equals 0, or x is equal to the 3/2. I think we should just go along with the first derivative test, because I don't think it's going to be hard to plug in numbers on either side. Okay, so the first derivative test, I've got x, this is f prime. I've got my critical point of 3/2. If you plug in, for example, 0, which 0 is over here, again, this is, I wrote can never be 0. This is actually always positive. So like that's a positive number. And then 2 times 0 minus 3 is a negative. Okay, so our function is decreasing in that section. And then if you plug in like 10, again, you'll get like a positive times 2 times 10 minus 3 is a positive. Okay, oops, sorry. And so the function changes to increasing. And now we've got a min by the first derivative test at 3/2, which is answer choice C. Okay, if you're going to take something from this problem, first remember the chain rule, and then also that little clue about e to the x squared minus 3x squared never being 0. That's really useful. It means you could divide by it, because you just can't divide by 0 in math. So you could divide both sides by that, leaving you 2x minus 3 equals 0, which gives us our lone critical point.